let's continue. Okay, so we were talking about the two forms of phytochrome. What are the two forms of phytochrome? The two forms of phytochrome are PR, sorry, PR, and the other form is PFR. Okay, so in the daytime, there, as I told you, the daylight has the sunlight. Let me draw the sun here. Oh no, I've made a mistake. Okay, so let me just draw this instead. There is the PR and the PFR. So the PR form is the light absorbing form, which absorbs maximum light in the red wavelength, which is from 660 nanometer. Okay, 660 nanometer. Whereas PFR form is the form of phytochrome which absorbs the far red light, which is from 730 nanometer of wavelength. So usually in the daytime has maximum of red light and minimum of red light and minimum of far red light. Okay, so daytime has more red light than far red light. So if there's more red light, the PR form will be converted into, what will it be converted into? It will be converted into the PFR form. Whereas at night the PR form, which is far red, will be converted back into PR form slowly by decaying. Okay, so PR form is the more active form, whereas PFR form, is the more active form as compared to PR form. Now let us look at the situation in short day plants. Okay, in short day plants are plants which grow where they grow during, or they flower during the winters. Why? Because they require shorter days and longer nights. Okay, so in short day plants, what happens? Listen carefully. In short day plants, what happens during summer? What happens during summer? During summer, there are longer days and shorter nights. Longer days and shorter nights. And shorter nights. So as I told you, short day plants are plants which grow in winter. So during summer, what happens? In longer days, okay, in longer days, if you take a graph, if in longer days, if I draw a graph of the PFR form, okay, see, because of the longer days, that means longer sunlight is going to be, longer hours of daylight will occur, right? So more of PR will be converted into PFR, isn't it? So because more of PFR is produced, so if I draw a graph of PFR, if I draw a graph of the P far red, the far red form of phytochrome in the daytime, because so much of sunlight is there's so much of sunlight, so the PFR is very high, the level is very high. But once there is darkness, because it is summer, I'm talking about summer has longer hours of daylight, maybe 14 hours of daylight. Okay, but what about night? Night is very short. Okay, so in the day, let's say this is 14 hours of daylight, and then nighttime is 8 hours. So I will give nighttime here. This is the hour of nighttime. So how many hours of night? There will be only 8 hours of night. Okay, so as I told you earlier that the PFR form gets converted into PR form at night. How? By slow decaying. So in in summer, the night time is very less. So there is a point, okay, there is a point here. Let me draw this point. This point is called as the threshold point. Threshold point. What does the threshold point mean? It means that the PFR form should cross this point, okay. So because in summer there are longer daylight, there's longer daylight and shorter periods of darkness, so the time for PFR to be converted back into PR, or to be, we can say that PFR number, the level of PFR is decreasing, right? But because of less hours of darkness, it cannot reach the threshold level. It is not, it should be, it should be less, but because of the less hours of darkness, again sunlight appears, right? So this period from here is when the daylight comes back. This also is the daylight. Okay, so the daylight comes back, and so when the daylight comes back, what happens? PR gets converted to PFR again. So at this point here, again PFR will be synthesized. So again PFR will be synthesized. Okay, so can you see that in short day plants, the PFR is, it cause inhibition, it inhibits flowering. Okay, because in PFR, if there is PFR in summer, if there is more PFR, then it cannot flower, it inhibits flowering. But what happens, this is talking about long in summer, okay, when there is longer days and shorter nights. Okay, but since it is a short day plant, what is a short day plant? A short day plant is a plant which produces flowers in winter, right? So let's see what happens in winter. So I will show you the scenario in winter. In winter, there are longer nights and shorter days, right? So if I draw a graph of the winter hours, suppose the daylight is this much, and this is the uh, hours of darkness, which is longer in winter, and then comes back the daylight, which is shorter. Okay, so as I've told you that there is a point, there is a period, a threshold level where PFR must be reached in order for the short day plants to flower. Okay, so let's see. In winter, what happens? In winter, because of the daylight, the PR will convert to PFR, right? So the PFR here, PFR will be produced, okay, maximum. But when the night happens, this is the night time, it's longer, isn't it? The longer hours of night will cause the PFR to be slowly decaying. That means the level of PFR is converted back into PR. So it will reach a point where it crosses the threshold level. Can you see? It crosses. Okay. Again, in summer, when the daylight comes back, it will be converted into PFR again. The PR will convert into PFR. So can you see that it has crossed the threshold level, which means that no more less there is less amount of PFR in short day plants during the winter season to cause the plants to flower. Okay, let me repeat that line again. There is less amount of PFR now in winter because of the shorter day length and the longer night to induce flowering in short day plants, because PFR is very bad for short day plants. It will inhibit flowering. Okay, so that is why short day plants flower in winter, because the PFR levels are decreased, okay, in winter, whereas in summer the PFR level cannot decrease beyond the threshold level. So that is the meaning of the PFR, the meaning of the role of the phytochrome in short day plants. Okay, now let us look at the next part. I will explain.